junction.
The substance that I choose is butane. Its common name is normal butane and its IUPAC name is butane. This illustration that you can see is the chemical structure of butane. It is an organic compound with a straight chain structure consisting of 4 carbon atoms bonded together with each carbon atom also bonded to 10 hydrogen atoms. Butane is an alkene with chemical formula of C4H10. Butane has several applications and uses. Here are some key ones. Fuel for portable camping stoves and lanterns. Butane is commonly used as a fuel source for portable camping stoves and lanterns due to its high energy density and clean burning properties. Lighter fluid. Butane is often used as a fuel for disposable lighters due to its flammable properties and ability to produce a consistent flame.
Hello, my name is Leonesa Almontejo. The substance I choose is acetic acid, and it's also known as vinegar acid. So its IUPAC name is ethanoic acid. Ethane plus oic is equals to ethanoic acid. Ethane indicates that there are 2 carbon atoms and oic indicates that it is an acid. The key to drawing this structure is realizing this COOH. So whenever you see COOH, you know it's going to look like this. So I'll put the C right here and the H's around it. In the acetic acid Lewis structure, we have the 24 valence electrons. I just want to inform you what is its applications or uses. So acetic acid is used as a sour agent added in vinegar, pickled vegetables and sauce, and as a raw material for spice. When used as a food additive, acetic acids can be indicated by its group name, substance name, or abbreviated name according to the purpose of use. Acetic acid is also used in food preservation in 2 forms, namely as 5 to 10% vinegar and as 25 to 80% aqueous solutions of synthetic acetic acid.
The substance I choose is the benzene. Benzene does not have common name in the same way that many other chemicals do. This is because benzene was one of the first aromatic hydrocarbons to be discovered, and it was given its systematic name very early on. The systematic name has stuck and there is no widely recognized common name for benzene. The chemical formula for benzene is C6H6. It has 6 hydrogen atoms and 6 carbon atoms and has an average mass of about 78.112. The structure has 6 carbon ring which is represented by hexagon and it includes 3 double bonds. The carbon atoms are represented by a corner that is bonded to other atoms. Benzene is utilized by some companies to create other compounds that are used to produce nylon, synthetic fibers, polymers, and resins. Additionally, several lubricants, rubbers, dyes, detergents, medications, and pesticides are made with benzene. It's important to note that due to the health risk associated with benzene exposure, its use in consumer products has been greatly reduced. In fact, many countries have regulations in place to limit or eliminate the use of benzene in consumer goods.
What is the substance you choose? The substance that I choose is butyric acid. So what is its common name? The common name of butyric acid, it is also called butanoic acid or propylformic acid or ethyl acetic acid. So what is the IUPAC name for butyric acid? The IUPAC name for butyric acid, I put here butanoic acid since butyric acid has a 4 carbons. That's why I put here but, and since it is single bond, butane, and in a carboxylic acid, the IUPAC name for butyric acid is butanoic acid. Since oxygen has a double bond, or oxygen is a double bond, that's why the IUPAC name for butyric acid is butanoic acid. So, present or illustrate the chemical structure. So, I said earlier that butyric acid composed of 4 carbons. So, this is my illustration. And then, in first carbon, there is 3 hydrogens indicated here. And the next one has 2 hydrogens, and the third one has 2 hydrogens, and the last carbons has a double band oxygen, and a single band oxygen, and single band hydrogen. So this is the chemical structure for butyric acid. Next is, what is the molecular formula? So the molecular formula for butyric acid. So since in the first carbon there is 3 hydrogens, so I put here CH3, and then next one is 2 hydrogens CH2, and then next is 2 hydrogens CH2, and a double band oxygen, so COO, and the single band H. So this is the molecular formula. This is the molecular formula for butyric acid. And then the last is, what is its application or uses? Butyric acid has several applications in different industries. In the food industry, it is used as flavoring agent to give a characteristic buttery taste, especially in certain types of cheeses and baked goods. It is also used in the production of esters for artificial flavorings.
Good day everyone, my name is James Dentular, and the substance I choose is a malt sugar. A malt sugar is a common name of maltose. And the IUPAC name of maltose is 2-hydroxymethyl-6, 4, 5, and 6 -tridoxy and -2-hydroxymethyl oxide 3YL, and oxane 3, 4, and 5 -triol. Moreover, here is the illustration of the chemical structure. The molecular formula of maltose is C12H22 and O11. The importance or the uses of maltose is used in bakeries, soft drinks, candies, alcoholic beverages, and infant foods, as well as incorporated into sugar-free products.
My name is Glidel K. BPM BFPT1A. The substance that I choose is starch. The IUPAC name for starch is amylose. The molecular formula for starch can be represented as C6H10O5N, where N represents the number of repeating units in the polymer. Starch is a polysaccharide composed of glucose units, and its exact molecular formula can vary depending on the type of starch and its degree of polymerization. Here is the simplified presentation of chemical structure for starch. This simplified structure represents the repeated glucose units linked together in both amylose and amylopectin molecules, which make up starch. Starch, a complex carbohydrate found in plants, serves various essential applications across industries and in everyday life. Starch serves multiple purposes in a food laboratory setting. It's commonly used as a thickening agent in various recipes, helping to create desired textures in food like soaps, sauces, and gravies. Starch is utilized in food experiments to detect the presence of certain substances, such as iodine test for the presence of starch in a solution. It can be used as a substrate in enzymatic assays to measure the activity of amylase enzymes. Overall, starch plays a crucial role in both culinary application and scientific analysis, within a food laboratory environment.
My name is Janmark F. Luwagi from BFPT 1A. The substance that I choose is the monoammonium phosphate, also known as ammonium dihydrogen phosphate, and has a chemical formula of NH4H2PO4. So this substance is commonly used as a fire extinguishers in the kitchen, and this is its chemical formula. So as you can see, there are 3 molecules of NH4 and 4 atoms of oxygen. Its IUPAC name is xanium dihydrogen phosphate, because that's what they think it is. That's all. Thank you.
Good day everyone. I am fixing your one. The substance I choose is the organic acid, commonly known as lactic acid. The chemical structure of this substance is illustrated as CH3, CH, C. We have actually 2 functional groups here. One here, and here also. So, the IUPAC name of this substance is read as 2-hydroxypropanoic acid. Why? Is it because this functional group has the highest priority rate of writing the IUPAC name? So, we have to write it first. So, 2-hydropropanoic acid. Propanoic because we have 3 carbon atoms here, and noic is the suffix we use, and the carboxylic functional group acid. So, the molecular formula of this substance is carbon 3, since we have 3 carbon atoms here, hydrogen 6, 1, 2, 3, 4, 5, and 6, and oxygen 3, 1, 2, and 3. So, the lactic acid plays an important role in food industry because it serves as a preservative, pH regulator in order to prolong the shelf life of our food. And other than that, it also serves as a leavener in baked goods and products such as pastry, cookies, and bread.
Everyone, I am Jovi Jane. The substance that I choose is caffeine, so known as caffeine in our coffee. So this is the illustrations of chemical structures of caffeine. And the molecular structures is carbon 8 because it has 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 carbon. Then it has 10 hydrogen, which is 1, 3, 6, 9, and 10. H10. And 4 nitrogen. 1, 2, 3, 4. 4 and 2 oxygen. 1, 2. And the IUPAC name is 137 trimethyl urine dash 2,6 dione. Caffeine is also known as used of foods and beverage market where it stimulates effects of the central nervous system.
Hi everyone, I'm Jerilyn Tumagna. The substance I choose is fructose. The common name of fructose is fruit sugar. So the chemical structures of fructose is this is the chemical structures of fructose. This is the molecular formula of fructose. Carbon 6 is dili ta masuro ihap. 1, 2, 3, 4, 5, 6. Manang 6 ang butang. A12, yung hydrogen is 12. Kubok 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Manang hydrogen 12. Yung oxygen 6. 1, 2, 3, 4, 5, 6. So, ang butang nila, oxygen 6.
The
The IUPAC name is fructose. Fructose contributes many useful physical and functional attributes to food and beverage applications, including sweetness, flavor enhancement, humidity, color and flavor development, freezing point depression, and osmotic stability. That's all, and thank you for listening.
Fight. Round 2, ice. Round 3, bite.
Good day everyone. The substance I chose is sodium chloride.
Round 3, bite. Okay.
The common name of sodium chloride is salt, table salt, or common salt. I'm gonna show you its IUPAC name, chemical structure, molecular formula, and its uses. Its IUPAC name is sodium chloride, and it is an ionic bond. Sodium chloride, commonly known as table salt, is an ionic compound with a chemical formula NaCl, representing a 1:1 ratio of sodium and chlorine ions. Na is for sodium and Cl is for chlorine, and that's why it is NaCl. So what is the use of salt or sodium chloride? It flavors food and is used as a binder and stabilizer. It is also food preservative as bacteria can thrive in the presence of a high amount of salt. Salt also plays a crucial role in maintaining human health. It is the main source of sodium and chloride ions in the human diet. Sodium is essential for nerve and muscle function and is involved in the regulation of fluids in the body. Sodium also plays a role in the body's control of blood pressure and volume.
The substance that I choose is Valen. Common name and the IUPAC name of Valen. Valen itself is actually the most common name for this amino acid. While it has other names, Valen is the most widely used in scientific contexts and nutritional discussions. 2-amino-3-methylbutyric acid. This is the IUPAC name, a systematic way to name organic compounds based on their structure. 2-aminoisovaleric acid. This is another chemical name for Valen. The specific structures of Valen is indicative of its chemical formula C5H11NO2. The structure attaches to the central carbon of amino acid backbone as R group. Valen is a branched chain amino acid molecule which is molecule that looks like Y. The molecular formula of Valen is C5H11NO2. C5, there are 5 carbon atoms. H11, there are 11 hydrogen atoms. N1, there is 1 nitrogen atom. O2, there are 2 oxygen atoms. Application or uses. Essential amino acids or Valen is a branched chain essential amino acid of BCAA, meaning it cannot be produced by body and must be obtained through dietary source. Valen is found abundantly in protein-rich foods like meat, fish, dairy, and soy. It's also present in some nuts, vegetables, and whole grains. While Valen offers potential health benefits, consult a healthcare professional before taking supplements, especially if you have any underlying medical conditions.
Hi everyone, I am Angel Liganya. So, the substance that I choose is the pentane. Its common name is pentane. Its IUPAC name is N-pentane. Its molecular formula is C5H12. So, we are going to talk about right now the chemical structure. So, since we have the chemical formula C5H12 in which the carbon is 5 and the hydrogen is 12. So here is the chemical formula. Now we're going to count how many carbons we have. So 1, 2, 3, 4, 5. We have the carbon, in which the C5. And now we're going to count the hydrogen, in which is it's 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here is the hydrogen, which is 12. So it is now the chemical structure of the pentane, the C5H12. The application and uses of pentane is in food industry. Pentane can be used to make foam products like insulation of foods for keeping it cold, flotation devices for safety in water, and packaging materials to protect food during packaging and shipping. Also, pentane can also be used to help to heat the refrigerator.
Hello everyone, my name is Susan and let me discuss to you the substance that I choose, its common name, IUPAC name, molecular formula, and the application or uses of the substance that I choose. Okay, so the substance that I choose is alcohol. It is specifically ethanol. It's a clear, colorless liquid that is commonly used as a solvent, fuel, and intoxicating beverage, and its common name is ethyl alcohol, and the IUPAC name is ethanol. The chemical structure of ethanol is consists of two carbon atoms bonded to a hydroxyl group. And this is the chemical structures of ethanol, which consist of two carbon atoms and bonded to a hydroxyl group. And the molecular formula of ethanol is that C2H5OH. And the last one is application or uses of ethanol. Ethanol is used in a wide range of applications, including as a solvent in the production of varnishes, perfumes, and pharmaceuticals. It is also used as a fuel, additive, and in alcoholic beverages. Ethanol has antiseptic properties and is used in hand sanitizers and disinfectants.
Modesa, here in front of you to answer the questions for our performance innovative task in organic chemistry. So the first question is, what is the substance that you choose? So the substance that I choose is pipernegrum or pepper. So the second question is, what is its common name? So the common name for pipernegrum is pepper. The third question is, what is its IUPAC name? So the IUPAC name for pepper, specifically black pepper, is pipernegrum. Fourth question is, present or illustrate the chemical structure. So, pepper, specifically black pepper, contains the alkaloid which is responsible for its pungent taste. So, here's the chemical structure of piperine. So, here as you can see is the chemical structure for piperine. This representation shows the atoms and bonds in piperine, so the main active compound found in black pepper. So what is the molecular formula? So the molecular formula for pepper, specifically for black pepper, typically refers to the chemical compound responsible in its characteristic flavor, which is piperine. So the molecular formula for piperine is C17H19 and O3. So the last question is, what is its application or uses? So piperine, the primary alkaloid in black pepper, finds various applications in chemistry. Uses include serving as a key component in organic synthesis reactions, particularly in the synthesis of pharmaceutical compounds due to its unique structure and reactions. So furthermore, its role extends to the field of food chemistry, where it is employed as a flavor enhancer and preservative in food products. So overall, piperine's diverse applications in chemistry underscore its significance as a versatile compound with various industrial and scientific uses.
Duran, before we start, let me introduce myself first. I am Romelyn Masabot from BFPT1AM. So now, there are 6 questions that I'm going to answer in this video that given by our instructor, Ma'am Mitchie Roa. So the first question that I'm going to answer now is, what is the substance that I choose? Since Ma'am Roa instructed us, we need to choose a substance that connected us as a BFPT student or use it when doing our laboratory. So the substance that I choose was ethane, since ethane is an organic compound belonging to the alkane family. So the second question was, what is the common name of the substance that I choose? So the common name of the substance that it choose, which is the ethane, is the bimethane or the dimethane. So now let's proceed to the third question, which is what is the UPAC name of the substance that I choose? Since the substance that I choose was ethane, so the UPAC name of ethane is simply as ethane. Ethane, the UPAC nomenclature system is used to systematically name organic compounds based on their structure and functional group. In the case of ethane, the name is derived from the number of carbon atoms in the molecule. And now let's proceed for the fourth question, which is present or illustrate the chemical structure of the substance that you choose. Since the ethane was the substance that I choose, so I'm going to illustrate you all guys the chemical structure of the ethane. And now I'm going to show you guys. So ethane contains 2 carbon atoms and 6 hydrogen atoms. So carbon atoms can participate in up to 4 chemical bonds, while hydrocarbons can have single, double, or triple bonds from the molecular formula of ethane. So it contains of 2 carbon atoms bonded together with a single bond. And for the fifth question is, what is the molecular formula? So I'm going to show you guys the molecular formula of the ethane. So as you can see that, as I said earlier, that ethane contains 2 carbon atoms and 6 hydrogen atoms. So let's proceed for the last question, which is, what is the application or uses of ethane? So ethane can be used in the production of detergents, since Mamro was said that we are going to choose a substance that connected us as a BFPT students, or that we are using inside of the laboratory. Since we are using the detergents to clean the utensils in our laboratory, so that's why I'm choosing this ethane, because it can be used for the production of detergents, which is the detergents can help us to clean the utensils inside of our laboratory. That's all. Thank you for watching.
Monosodium glutamate, or let's say MSG, is the material I have selected since it widely used in a variety of industries such as food manufacturing, the culinary arts, and medicine. It is a common element in many applications due to its adaptability and broad acceptance. MSG is most often known by its plain common name, monosodium glutamate. This word is widely used in culinary contexts and on food labels in general. The UPAC name of MSG is this. This is the chemical structure. This structural formula illustrates the arrangement of atoms in MSG, with a sodium quotient Na+ bound to the carboxyl group of the glutamate molecule. The molecular formula of MSG is this, which denote its chemical composition containing 1 sodium atom, 5 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms. This concise formula provides insight into its elemental composition. Is always used in food production to boost flavor, particularly in dishes such as soap, sauce, snack, and processed meat. So, thanks to its ability to enhance umami taste.
The substance that I chose is ascorbic acid. The common name for ascorbic acid is vitamin C. The IUPAC name for ascorbic acid is 1 and 2 dihydroxyethyl and 3 and 4 dihydroxyfuran. As you can see, here is the chemical structure of ascorbic acid. The molecular structure, it has 6 carbon, 8 hydrogen, and 6 oxygen. The molecular formula is C6H8 and O6. Ascorbic acid or vitamin C has numerous applications and uses. Some of its key uses include food preservation. Ascorbic acid is used as food preservative due to its antioxidant properties. It helps prevent the oxidation of fruits and vegetables, maintaining their color, texture, and nutritional value. It is also used in the production of processed foods to prevent spoilage. Food beverages Fortifications, ascorbic acid is added to various food and beverages products to fortify them with vitamin C. It is used in juices, beverages, fortified cereals, and other food products to enhance their nutritional value.
Hi everyone, I'm Maji Gumapet and the substance that I choose is glycerin. Glycerin is a type of carbohydrate called sugar alcohol or polyol. Its common name is glycerol. This is its chemical structure.
It's a polyol compound that contains 3 hydrolyl groups and 3 carbon atoms. Each hydrolyl group is covalently bonded with a carbon atom.
Its IUPAC name is propane 1,2,3-triol. Its chemical formula is C3H8O3. Its applications and uses. In food and beverages industry, glycerin is employed as a humectant, sweetener, and dissolvent. It is also used as a preservative for the storage of food items. This is also known to be used in commercially packaged low-fat foods such as cookies as a filling.
The substance I choose is propionic acid. Propionic acid is an organic molecule that can be made from the fermentation of sugars and the composition of amino acids. This natural process is led by a specialized bacteria by the name Propionibacterium strains. The common name of propionic acid is propanoic acid, and the IUPAC name is propanoic acid. So this is the chemical structure of propanoic acid. The molecular formula of propanoic acid is this.
What is its application and uses?
Propionic acid is a chemical used to help preserve and flavor cheeses and baked goods like breads and tortillas. It's also used as an antifungal and antibacterial agent in agricultural and livestock operation.
Hello everyone, I am Marian Ilakdain and I'm here to explain the substance I chosen, and I will provide its common name, the IUPAC name, the chemical structure illustration, the molecular formula, and its application or uses. Ethylene is a colorless flammable gas with a faint sweet odor. It is a hydrocarbon and belongs to the group of alkenes. Its common name is simply ethylene. The IUPAC name for ethylene is ethyl. The molecular formula of ethylene is C2H4, indicating that it contains 2 carbon atoms and 4 hydrogen atoms. Here is the chemical structure of ethylenes. Ethylene's chemical structure is represented by 2 carbon atoms double bonded to each other and each bonded to 2 hydrogen atoms. Ethylene is used as a ripening agent for fruits. Ethylene is a gas that helps fruit ripen. It's like a natural signal that tells fruits it's time to become ripe and tasty. Farmers and food companies use ethylene to make sure fruits like bananas, tomatoes, and avocados are perfectly ripe when you buy them. They also use it to keep fruits fresh for longer during storage and transport. So ethylene is like a helpful tool that makes sure the fruits you eat are just right.
Cocoa butter, primarily choose for its widespread utility across various industries, including chocolate manufacturing, skincare, and pharmaceuticals, owing to its versatile properties and beneficial attributes. Cocoa butter is commonly referred to by its common name, cocoa butter, which succinctly captured its origin from cocoa beans and its characteristic butter-like consistency and room temperature. Its IUPAC name is an hexadeconic acid, 3-hydroxane, 2-hydroxymethylpropylene ester and nomenclature indicating its chemical structure consisting of hexadonic acid, palmatic acid, and 3-hydroxine, 2-hydroxine methylpropylene alcoholic glycerol forming an ester link. The chemical structure of cocoa butter which a molecular formula of C18H36O2. Cocoa butter comprises 18 carbon atoms, 36 hydrogen atoms, and 2 oxygen atoms per molecule, delineating its elemental composition. Cocoa butter finds extensive application as an ingredient in chocolating fabrication, skincare, formulation, and pharmaceutical preparation due to its unique melting characteristic, moisturizing properties, and compatibility with various compounds, serving diverse purposes in each industry segment.
The substance that I choose is baking soda. Okay. What is the common name of baking soda? The common name of baking soda is sodium bicarbonate. And also, what is the IUPAC name of baking soda? The IUPAC name of baking soda is sodium hydrogen carbonate. Okay, this is the Lewis structure The molecular formula of baking soda is sodium hydrogen carbonate. The application or uses of baking soda is versatile ingredient whose use extends far beyond cooking. This household staples shines when it comes to neutralizing odors and cleaning, as it helps remove stuff, stains, eliminate foul odors, and clean difficult areas like oven, microwave, and the tile ground.
Good day everyone, my name is Altia Di Batukael. The substance that I choose is alcohol methanol. Then the common name is methyl alcohol. Dayon ang iyang chemical structure is mauni siya CH3. Dayon naa siya functional group nga ang tawag niya is hydroxylic acid or alcohol. Dayon ang iyang chemical formula is CH3OH. Ang uses ani na substance ay ang methanol occurs naturally at lowest level in fruits, vegetables, juice, and other foods prepared from fruits and vegetables. Maong gitawag siyang methyl alcohol kay isa naman iyang carbon, dayon ang tawag ani is met. Dayon ato man giad ang suffix sa hydroxylic acid or alcohol mo nang atong gikuha ang OL, then natawag ni siya og methanol. That's all, thank you.
So this picture is about the substance that I choose. The first question is, what is the substance you choose? The substance I choose is momardicin, commonly known as a better melon. Second question is, what is the common name? Common name is better melon. Question is, what is the IUPAC name of momardicin 1? The IUPAC name of momardicin is this. And the fourth question is, present or illustrate the chemical structure. This is the chemical structure. Next question is, what is the molecular formula? The molecular formula of momardicin 1 is this. And the last question is, what is application or uses?
I am KCR Painagan, so I am here to explain the substance I have chosen. I'll provide its common name, EUPAC name, chemical structure illustration, molecular formula, and its application and its uses. The substance I choose is organic acid, commonly known as oilic acid. Oilic acid is a predominant component of olive oil. Oilic acids present in olive oil is one of the reasons this oil is considered a healthier option due to its ability to reduce bad cholesterol levels in the blood, which is linked to a lower risk of heart disease and stroke. And its common name is oilic acid. And its EUPAC name is 9Z-octadic-9 ionic acid. The chemical structure of oilic acid is featured a long carbon chain, 18 carbons with a single double bond between the 9 and 10 carbon atoms, counting from the carboxyl end, which is in the cis configuration, Z configuration in EUPAC nomenclature. And its molecular formula is 18 carbon, 34 hydrogen, and 2 oxygen, or C18, H34, and O2. What is its application or uses? In cooking, oilic acid, as a major component of olive oil, is widely used in cooking, both for frying and as a salad dressing due to its health benefits and flavor.
Good day everyone, I am Amabel K. Kanyas and I am here to explain the substance I've chosen. I'll provide its common name, EUPAC name, the chemical structure, illustration, the molecular formula, and its application or uses. The substance that I choose is hexane, commonly known as the processing aid of extraction of different products. The EUPAC name of this substance is hexane, and the molecular formula is 6 carbon and 14 hydrogen, or C6H14. So here is the chemical structure of hexane. It has 6 carbon atoms and 14 hydrogen atoms, and it is a single bond. The application of this substance, it is a solvent used extensively in food industry for the extraction of various products such as vegetable oils, fats, flavors, fragrance, color additives, or other bioactive ingredients, as it is classified as a processing aid.
The substance that I choose is sugar. The sugar is commonly known as sucrose. So the EUPAC name of sugar is sucrose, and the molecular structures, it have 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. So here is the chemical structure of sucrose. It has a 12 carbon atom, a 22 hydrogen atoms, and 11 oxygen atoms. The application of this substance is widely used in foods preparation for its sweet taste. It is also used in preparing foods, in fermentation processes, and even in certain medical applications.
Hello, my name is Christian Carla Malvius, and the substance I chose is citric acid. So citric acid is a weak organic acid found in citrus fruits like orange and lemon. So its common name is citric acid, and its EUPAC name is 2-hydroxypropane 1,2,3-tricarboxylic acid. So its chemical structure is this. So if you cannot see it properly, I will just put it here. And citric acid has a chemical formula of C6H8O7 and a molecular weight of 192.124 grams per mole. So it contains 3 carboxylic acid functional groups and 1 hydroxyl group. So citric acid is commonly used as a flavoring and preservative in food and beverages. It is also used in pharmaceutical industry as an antioxidant and a stimulant. Additionally, it is used in cleaning products as a chelating agent in cosmetics and personal care products.
I'm Jogavishwati Ritando, and the substance that I've chosen was green onion, which contains sulfur dioxide. So technically, I will discuss sulfur dioxide, and I'm also going to show you now the chemical structure and the molecular formula of sulfur dioxide. So let's have a look. First, we have to tackle here the chemical structure of sulfur dioxide. So in sulfur, we have 6 valence electrons. In oxygen, we have also 6 valence electrons. And since we have 2 oxygen atoms here, so that should be 12. So overall, you add that 6 plus 12 is you have overall 18 valence electrons. So that's it. So let's verify that through counting this the Lewis structure dots. 2, 4, 6, 8. So it follows the octet rule. Then the other one, 2, 4, 6, 8. It also follows the octet rule. And the last one is this element sulfur, 2, 4, 6, 8, 10. As you can see, it did not follow the octet rule, and the only plausible explanation for that is that sulfur could hold more than 8 valence electrons, and so it does not necessarily need to follow the octet rule. So that's it. And lastly, the molecular formula for sulfur dioxide is this: 1 sulfur atom and 2 oxygen atoms. So that's it. And lastly, the uses of onions, which contain sulfur dioxide. First, it can enhance the flavor and aroma of the food or the dish that you prepare. Then also, it can prolong the shelf life of the food. And that's all.
Hello, good day everyone. My name is Kriza Nelias Alban. I am here to explain the substance I have chosen. I will provide its common name, IUPAC name, chemical structure illustration, molecular formula, and its application or uses. The substance I chose is water, commonly known as water, and its IUPAC name is oxidane. The chemical structure of water arises from the sharing of electrons between 1 oxygen atom and 2 hydrogen atoms, forming covalent bonds that results in a stable molecule, making H2O the most thermodynamically favorable configuration. This arrangement is represented as HOH, with the oxygen atom at the center and 2 hydrogen atoms bonded to it. And the molecular formula is H2O. What is its application or uses of water? Water is essential for life and has numerous applications, including drinking, cooking, agriculture, industrial processes, transportation, and as a solvent in chemistry. Water is important for our lives because it is necessary for the functioning of our bodies, ecosystems, and societies. It plays a crucial role in maintaining health, supporting economic activities, and sustaining the environment. Access to clean and safe water is essential for human well-being and development.
The substance that I choose is propane. The propane is commonly known as liquefied petroleum gas or LPG. The IUPAC name of this substance is propane.
And the molecular structure is 3 carbon atoms and 8 hydrogen atoms. Here is the chemical structure of propane. It has 3 carbon atoms and 8 hydrogen atoms, and it is single-banded. The application of this substance include home and water heating, cooking and powering farm and industrial equipment.